Hi, I'm Markus Gärtner from IT Agile, and we got a CodersDojo.org website where you can perform coding katas on your own. And we also got a command line client, which I'm going to show you today. So, in order to get started, we need to install the gem holding the CodersDojo command line client. Downloads everything, installs the gem, and then we should have empty directory. And if we invoke now CodersDojo help, then we get the help. So we have set up our upload. We don't have kata finished yet, so what we're going to do is we set up a kata here. CodersDojo, we're going to perform the prime factors kata, and let me see what we have here in the setup. So we have CodersDojo set up Ruby test unit for primes without the extension. Now we got basically a readme, we got a run endless sh, and we got a run once sh, and we got our empty kata. So what we're going to do here is on the right side, let's run the shell script run endless, which is endlessly checking whether or not you changed anything in your kata. As you can see, it prepared already something. So if we now invoke vi primes, we see there is basically a good start to get started. So let's change that. First of all, let's remove these. Now the first test in the prime factors kata would be to have primes of 1, and these are assert equal primes of 1 should be empty set. Okay, now let's save this. Okay, we got an error. The problem is here there's no method of. So let's first of all get rid of this one. Define the self of number, and alright, now the test is failing. Now in order to make it green, let's simply return what we have there. Now the test is passing and we can continue with the next test. So def test primes of 2 should yield a list with just the 2, and save it, runs the test, and so we got one failure because we have an empty list where the 2 should be in there. So let's fix that. So we return 2 if number equals 2. Voila, it passes. Alright, next test. Def test primes of 3. Assert equal. The 3 just gets the 3 like the 2 did, but we want to develop now the algorithm here. Saved. Test is failing on the right, so let's take a look on the left. We put in here the number if the number is larger than 1. And this makes the test green. Okay, in order to prepare the next step, I want to refactor here a bit. Let me put the empty list into results. Test still passing. Now we just enter here the result in the end. Tests are still passing. Now instead of returning, we're just going to shift the number into the result. If the number is larger than 1. tests are still passing, and if I now delete this line, they're still passing. Alright, now it should be easier to make the test for the primes of 4 here, because if we now have a list of 2 2s, then we can make use of our result. Now we got one failure because the 4 is included there. So instead of doing this thing, we're going to add 2 and divide the number by 2 if number is divisible by 2. Alright, this works. Great. Next test is the test for the primes of 5. So we assert here, upper E, that we got the 5. This is yet passing. Let's take a look at the primes of 6. Primes of 6, just 2 and the 3. Oh, they're passing. Why are they passing? I'm confused. Oh, we add the 2 and then we add the number because it's larger than 1. Okay, so this is fine. The 7 should yield just the same result as the 5 did, so we're going to skip this thing and we're going to deal directly with the primes of 8. Primes of 8 are just 3 2s, and we got, there's a space missing here. Alright, now we got a failure test. Now we can make progress. Let's take a look what we do here. So what we do here, Uncle Bob Martin recently called this transformation. We simply change the if to while, and then we have passing test again. So the next one, which concludes our algorithm basically, is test primes of 9. Assert equal, we're in Ruby here, 3 and the primes of 9. And this one will certainly fail. So we now need to fix that one. We're going to extract the 2 here into a candidate. So the candidate equal 2, and we add here the candidate all the time. Candidate. Now let's take a look if this is passing still. It's still passing. Only error there is the 9 which we last added. Now what we are going to do is that we are going to deal with while the number is larger than 1, we add this one and we increase the candidate by 1. This should make the last test pass, as we can see on the right. So this looks not so optimal. First of all, this statement now becomes obsolete. We can safely delete it, as our tests are going to tell us. We can combine steps here. But I'm going to leave it like that. So it's not my premise to show the prime factor scatter. There are way more better videos showing the prime factor scatter. I'm going to show the CodersDojo client's use here. So let's add some acceptance tests to the primes of acceptance. So we got equal. We should get 19 2s for the primes of 2 to the power of 19. We do. Right. We should assert equal, should get for 2, 3, 5, 7, 11, and 13, and 17, if we have the multiplication of these, 2, 3, 5, 7, 11, 13, 17, and it's still passing. Alright. Now, this is enough for me. Now we're going to add this run endless sh here on the right in order to upload our statistics. Alright, I press Ctrl C in order to abort the script. Now we got still primes are reading there. So what we're going to do now is let's invoke CodersDojo help on the upload statistics. CodersDojo upload should upload the last kata we performed. So we should basically be finished if we just invoke upload. Oh, it wants to have Ruby test units. And it needs the session there. This is the one. It's in a hidden subdirectory. Now we got 24 states, 24 steps. It uploads them, and in the end, it should tell us something about our performance here. Uploaded. Okay, we got here a shortened link. Let's copy this one into Safari, which should open but does not. Come on, okay. And ta-da, here's our performance, as you can see. Alright, thanks for watching this introduction to the CodersDojo command line client. Please share whatever coding katas you perform. And if you find any problems, let us know. Thanks.